Welcome, everyone.
Welcome.
Thank you for joining. All right, it looks like our waiting room is all in. So we're ready to get started. So I want to introduce myself. My name is Amanda Henley. I am the host of the virtual user groups. I apologize for my voice. I am getting over a cold. I am so glad I'm able to talk today because that is a new thing for me in the past week. So you won't have to hear much of me, thank goodness. Let's just jump right into it. We have a pretty easy agenda today. As always, we're going to introduce this session and make some announcements. We'll have our presentation, then we'll have some time for Q&A, cover any news and announcements, and then announce the date and speaker for our next session. I do want to thank our partner, BMC. They are a sponsor of the virtual IMS user group, and we couldn't do that without their support. If you're a company that's interested in sponsoring either the IMS or we have DB2 and KICS user groups, you can reach out to me directly. I am ahenley@planetmainframe.com. We appreciate your support, and it's also an opportunity for you to get engaged with the community. After the session today, when you leave, there's going to be an exit survey. It's 2 questions. It'd really help us if you would just answer those on your way out. Pretty simple survey. I don't think you'll need to study for it at all. Coming up in a couple weeks, Planet Mainframe and I will be at Share Orlando. So if you are going to be there as well, please come and visit me at booth 406. And we are going to have there copies of the Arcadi Mainframe yearbook that was just released about a week and a half ago. The yearbook features strategic papers, our 2024 mainframe user survey, and that's just a really exciting component because we surveyed all the mainframe users we could find, and we figured out where they were investing, where they weren't investing anymore, and what their struggles were and what the opportunities were for the next year. So a lot of really exciting information in there. There's also a great vendor directory and terminology glossary. So with that, I'm going to stop my screen share so that I can introduce our speaker today. Give me one moment to stop my share. And are you able to share your screen?
Hopefully, 1 second.
Okay. I'll go ahead with your introduction. Perfect. So Dr. Daniela Schilling is CEO of Delta Software Technology. She holds a PhD in computer science and has 15 years of experience in automated software modernization and evolution. After several years in the automobile industry, she joined Delta Software Technology in 2011. Since then, she has really focused on enabling large organizations to smoothly and securely adapt their large and complex COBOL and PLI applications with automated solutions. So with that, I'm going to turn it over to you to lead our session.
Yeah, hello and welcome to our talk today about replacing IBM IMS DB, fully automated and with high security. And at first, I'd like to thank Amanda for inviting us and giving us the ability to present, well, let's say our way or one way how to cope with this task. And well, the next slide is about me, but I think Amanda already thought a bit about me. It's nearly the same. So my name is Daniela Schilling and I'm CEO of Delta Software Technology. And yeah, my field of interest where I'm working on nearly every day is the automated re-engineering, modernization and software evolution, especially on large and complex COBOL and PL1 applications or applications generated with tools like Delta ADS. And my task is to create concepts, and in addition, I love to prove that they really work in customer projects. So projects belong to my tasks too. And of course, present the ideas and results like today, or like on conferences like the GuideShare Europe, as I'm located in Germany. So I think that's enough about me. More interesting is the topic of today, replacing IMS DB. And well, when it first crossed our way, we were wondering, why should anyone want to replace it? I mean, the IMS DB is performant, it's reliable, it's used for decades, it's part of big applications, and it's interwoven with the applications. Never change a running system. So why should anyone want to replace it? Yeah, the answers came from some customers, and they had really good reasons, or they mentioned good reasons why to think about it. And some of these reasons, and there might be much more reasons, are during the time when the application was developed for several decades, further technologies came into the application. So there is a parallel usage of different technologies for the same task. That means you have the IMS DB and maybe relational DBs within one application. And that means you have effort you need database administrators for both technologies. That means you have extra costs because you have double efforts. The complexity increases because of the different technologies. You have to take care that the data is consistent in both technologies, both databases. You get restrictions on what you can do and what you can't do due to this mixture of technologies. And using IMS database also means the data availability is limited. Of course, not in your COBOL or PL1 application. That's not a problem. But these applications usually run in an environment where you have newer other applications around, and they wanted to access the data too, and then you get into trouble. So there's a limited availability of the data. In some cases, there might be the goal of a platform change, and one of the most or the biggest problems is that the know-how about IMS is dwindling. In Germany, I don't know any university or school teaching IMS, and I don't know whether it's if it's something different in the US, but I think the know-how is dwindling there too. So these are some reasons, and there could be even more, but I think these are good reasons to think about replacing IMS, even though it's really reliable and performant. Two of our customers who thought about that and went the way together successfully with us and replaced the IMS DB are Provinzial, formerly Provinzial Rheinland, and Gotha. Both of them are insurance companies located in the Rhineland, Provinzial in Düsseldorf, Gotha in Cologne. And yeah, I show these two to you to show that the approach I'm presenting today is not only working on PowerPoint slides, but also in reality. And yeah, about Provinzial, the project was called Dino. It consisted of 36,000 sources, meaning COBOL programs and copybooks. Expanded, we had 70 million lines of code with about 16,000 database accesses to 75 IMS databases. On the other side of the Rhine, there was Gotha located, and their project was called GoBIMS. They had 45,000 sources COBOL programs and copybooks, and also Delta ADS, which is a generating system from us, generating COBOL sources. And their system had 50 million lines of code expanded and 5,500 database accesses and 447 databases, including history databases, from which we replaced 358 databases. So why only 358? Quite simple. Gotha deleted some of the databases because they weren't necessary anymore, on the one hand, and on the other hand, some of the databases were manually transformed by Gotha themselves. And another interesting point is that Gotha has much more databases than Provincial, but they had only 500 accesses, and that's due to the reason because they had some kind of, let's call it data services. So that's why they had less database accesses in their system. So this is just to give you some numbers where the approach worked pretty fine. And yeah, from now on, let's have a look on what are the challenges and the requirements when trying or when replacing IMS DB by a relational database. So in the beginning, you have programs, mostly COBOL or PL1 programs, which directly access the IMS database. And these programs shall be transformed in a way that they access a relational database instead. So it's quite simple, but of course there are some challenges. And the very first challenge is, you need a new data model, which fits to a relational database system. And of course, it's not it wasn't up to us to create this data model, but the customers had some requirements which we had to fulfill, or which have to be fulfilled. And second, and one of the biggest challenges is there is a paradigm change from a hierarchical to a relational database. But even though it's not allowed to change the application logic or the data structures, because that would mean that the test effort would explode. So no change of application logic or data structures. And the third one, as you can imagine, such a project takes some time. It's not done from one day to another day. And of course, that means there must not be any restrictions to the regular maintenance or daily business. That has to go on without any disturbance. So, yeah, and how can this be fulfilled? For large and complex systems, it's, from our point of view, impossible to do that manually. And therefore, we say you should use an automated approach. And our automation assumption says you can do projects using, let's call it peopleware, or you can do it using hard and software. And the assumption says, if you can explain your transformation rules to somebody located somewhere on the earth, then you should also be able to define the rules and tell them to your computer. But on the other hand, if you don't know the rules, you should better hesitate and do anything at all, because in that case, your project will fail. So the question is, how can such a task be automated? And we suggest to use a modernization factory. Such a factory can be individually made, means custom made from prefabricated configurable components. It should implement the clean room concept, which means that all processes are completely automated and controlled so that no contamination of the results is possible. And it should be model-driven and rule-based. Rule-based, model-driven and rule-based to realize the customization on the one hand, but we'll see later on it's also needed to ensure security mechanisms. So, and when looking at this, you can imagine such a factory similar to or consider such a factory similar working like an industrial factory. At the beginning, you have something. It's in entry or input. Of course, an application, bits or bytes, are usually not carried by a truck, but it has to be imported to the factory. It has to be brought to the factory. In the next step, you need an order describing what the factory should do on the raw material you brought into it. And then there's the main part of the factory, and you can think about it like there are a lot of robots doing the work. You can watch them doing the work, but you can't interfere. So there's no contamination possible. And that's what I called clean room concept before. At the end, when the robots did their jobs, they put everything into packages and deliver it back to the customer. And nothing else is a modernization factory. It's just doing the job on software instead of, I don't know, industrial goods. So that's the idea behind. And I'd say let's have a closer look into the factory, because that's where the interesting parts happen. And that's where the IMS is replaced by a relational database. So such a factory, this is the inside of the factory, has of course input. And input here means you have COBOL programs and copybooks, or Tier 1 programs and copybooks too, includes. You need PSBs and DBDs as input, and of course the IMS data has to be transformed too. So within the factory there are 3 tasks to be solved. At first, the transformation of the sources. Second, of course, the data model from old to new, and the data has to be transformed. The setup of this factory is an incremental process. And in each step, the customer is involved in our concept, which means the customer can influence the setup of the factory, but to some degree, the customer has to contribute into the development process to give us the requirements to be fulfilled, and to hand over programming guidelines and so on and so forth, and furthermore. So as soon as the factory is set up, you get some output, and the output of the factory here are transformed sources, a kind of data access, DDLs are generated, and of course the relational data is the result. So and here we have 3 tasks to be solved by the factory, and let's have a closer look on each of them. Such a project starts with the data model, because this is the essential task in the project. What is needed is, on the one hand, the old data model, and this can be automatically derived from PSBs and DBDs. And from there, a proposal for a new data model can be derived by analyzing the existing data structures, by analyzing the possible content of the segments, and by regarding the requirements for implementation of arrays and redefines, and so on and so forth. So this ends up with a proposal for the new data model. It's just a proposal. It's not yet fixed. And this proposal is discussed with the customer, meaning with the database administrators, and of course also with the application developers, because after the project, they have to continue to work on this new data model, and they may have some ideas in mind for improvement for the future. So there's a discussion at the end, and then there is a new data model and the mapping between the old data model and the new data model. This is not completely fixed, because our experience during projects showed that these projects are so complex that in the beginning of the project, it's nearly impossible to know all the details up front. So it has to be possible to adapt the data model during the project, maybe due to new technical demands of the application development team, or because of performance optimization, because it's necessary to do that. So yes, we do have a data model here, but it might be fixed or adapted during the project. So now we have the old data model, the new data model, and we have the mapping between the two of them, and everything agreed upon with the customer. So that is step one. Step two is the transformation of the application itself. To do so, all COBOL programs and the PSBs and DBDs have to be handled and analyzed by the factory to determine the IMS usage. So means searching for all IMS access within the application. And for each kind of access, IMS access, there has to be a rule specified how to analyze it and how to transform it. And as soon as these rules exist, there's again a meeting or a coordination with the customer to talk about the transformation, whether this transformation fits the customer's requirement or whether further adaptations have to be performed. And when there is an agreement with the customer, the transformation rules get implemented in the factory. And when they exist, of course, you can apply them to the sources and get your transformed sources. Sounds quite easy, but there are many rules to be implemented. And of course, IM has some, interesting features. And with each project, you find new rules to be implemented. But yeah, that's how it works. So, but there's one important point about it. I said in the beginning that the application logic must not be changed, because otherwise the test effort would explode. But so the factory changes the application, but not its logic. To enable that, we have to use, or we have to generate database accesses in a certain way. The challenge is we have a paradigm change from hierarchical to relational. For example, we have to take into account characteristics like arrays, redefines, and stuff like that. And that means a one-to-one transformation is not possible. So it's not possible to remove the IMS access by just, let's say, a line of SQL code. That wouldn't work. So if we don't want to change the application logic and or the data structures, there are data services needed, and that's looking like that. So we need data services, means the programs, instead of accessing directly the database, the programs call the data services, and the data services then access the relational database. And these services handle the data from the relational database as expected by the program, despite of the change of paradigm. Within these data services, the complete SQL-specific coding is encapsulated. And which database access is implemented in the data service, that depends on which IMS usages or IMS accesses exist in the programs. So the analysis has to find out which accesses do exist. The data service can emulate IMS PCB information like return codes or concat keys. And if possible, the implemented SQL should be static SQL, again, due to test reasons, because dynamic SQL is quite hard to be tested. The data service can implement a standardized error handling, and important requirements from our point of view for such data services, they have to be generated automatically, but after the project, the customer has to be able to maintain it manually. And again, the customer-specific coding standard have to be implemented in these data services too. A further advantage of these data services, even though it's not a requirement, is that if you want to change the database system again during the project or after the project, it's quite simple, because you do not have to touch the programs. Instead, you only have to adapt the data services to the new database system. It's not a requirement, but it's an advantage. It's a win you get on top. Okay, so now we transformed our application. We added data services. We have a new data model and the mapping in between. And now the programs can indirectly access our relational database. That's great, but there's one problem, because so far there is no data in the database. So somehow the data has to get from IMS DB to the relational database. And this can be optionally done by a data transformator. And we propose to generate such a program for the data sets. And yeah, it's working on the existing mapping rules of the data models. Means we have our IMS database on the left-hand side, do an unload of the data, and the data transformator takes this data, transforms it using the mapping rules into a relational data, and loads it back to the relational database. The advantage is that we use the same data model for the application transformation and for the data transformation. So that means if during the project it's necessary to adapt the data model, then these changes are automatically and synchronously updated in the application and the data transformator. And another advantage is the documentation of data transformation, because this data transformator, on the one hand, counts the number of data sets it's transformed, and if errors occur, they are documented too. And so far, in every project we did on replacing IMS database, we had some problems or errors in the transformation of the data. For example, because data had another type than expected. In IMS database, you can store it in another type than it was expected before. So this is how the data can be migrated. Is there a question? Okay. Sum up again all the components of the modernization factory in one picture. And so far we considered what is part of the factory and what has the factory to do, which transformation have to take place. But what I said in the beginning was this factory is set up in an incremental way. And I'd suggest we'd have a look on the incremental development of this factory too. At first, the factory is always or should always be set up customized. For example, take Gotha and Provinzial from the beginning. I mean, these are both insurance companies. They are located in the Rhineland with only a few kilometers in between and the Rhine in between. They both work on with COBOL. They both have an IMS DB, and they both wanted to replace IMS by DB2. So this sounds like two very similar projects. And yeah, it sounds as though you can use the same factory for both. But what came out during the project was that some of the performance optimizations we made for Provinzial led to performance problems at Gotha site and vice versa. So even though it seems to be quite similar, we needed to customize factories really fitting to the customer's needs. So yeah, we have to set up specialist factories. And this is done by, in the first step, receiving all sources from the customer, and all sources means all sources. Regardless whether they contained IMS access or not, all sources were needed. And with these sources, a basis factory can be set up. This basis factory is quite small, or seems to be quite small, because it only can import the sources, build models from the sources, all the models needed for further analyzations, like control flow, data flow, and so on and so forth. So this is just a basic factory. And in the next step, this factory gets trained. And the training of such a factory is done package-wise. Again, the customers ask which packages do you have, or which part applications do you have? And you should start with a simple package and not with the complexest one to train the factory. And for this, or during this process, all transformation rules for the first package are specified, discussed with the customer, implemented, and then the sources of package 1 are transformed and handed over to the customer to get feedback from meta-level test, or by analyzing runtime test, performance test, and so on and so forth. And as long as these tests are not successful, the results are put or are given back and used to train and optimize the factory. As soon as the tests are successful, there's a final transformation for the package, and it can be brought to production. And then the next package is used to train the factory, and so on and so forth, until all packages can be transformed. Yeah, as you can imagine, this takes some time. It can take quite a long time, not only a few days. And of course, the development and maintenance is going on. So the sources to be transformed change during that time. And therefore, at certain points in time, a current version of the sources has to be imported into the factory. And that can be certain points in time, or as we did it in former projects, we received the sources once a week and imported them into the factory so that we always worked on the current version of the sources. Yeah, and another point is this takes some time, and the project is quite complex. So at the very beginning of the project, not all requirements are clear. At some points, requirements change, and therefore the strategy for transformation needs to be adapted during the project, and that has to be possible at any time of the project. But when using a factory-based approach, that's possible because even though you already put your sources into production, your transformed sources into production, you can just put them into the factory again and transform them again. So that's not a problem. And that is one of the advantages of a factory. Okay, but there is, of course, a big point or a big task left to be done. And this big task is called testing. Of course, testing is very essential for such a kind of project. You have a large and complex system. You have thousands of accesses to the IMS database, which are replaced by the call of a data service, and this has to be tested. If you wanted to do that by a standard approach, you would have to test each performed change, and that's nearly impossible. So the effort would be much too high. And therefore, we suggest to use what we call meta-level testing. The factory is rule-based, and and we implement the clean room concept. And that's something we can use to reduce the test effort, because the idea behind is if an automaton or a factory replies a rule correctly once, it will do that always at any time. So it's not necessary to test every change in the application we made. Instead, each of the transformation rules have to be tested. And there are much more changes than transformation rules, so the effort can be significantly reduced. For these tests, you need, or they have to be performed on a selected but complete test set. And the good thing about it is that this test set can be automatically determined by the factory by combination of all applied rules. And to determine this test set, the factory can perform a coverage analysis telling which artifacts got transformed and which transformation rule was applied to which artifact. So this strategy can really reduce the effort for testing. But these aren't the only ways to reduce effort or to improve the security of the project. There are further points on quality and security. Quality and security are achieved by 100% automation, which means that every change that has to be performed and any new piece of software have to be generated or performed by an automated way. The clean room concept has to be strictly implemented, complete and controlled processes, so that no contamination by manual intervention is possible. Another advantage of a factory-based approach is there's no personal style. So when using or when doing it manually, it depends on whether developer A or B is doing the task. And well, the factory doesn't care about whether it's Monday morning, Friday afternoon, or even on Sunday. It's just doing a job. Each step is reproducible. So if you put the same piece of software in several times, you get always the same result, and it's comprehensible. Some mechanisms to ensure this, or some further mechanisms, are documentation and some, well, let's say optional mechanisms, which we call switches and verify. And well, documentation is the first of them. Documentation means the factory automatically marks each change which it performed, and that means it's giving a name, which change rule was applied and why. So the reason is written here. It tells whether a line was replaced, deleted, or inserted. And this documentation can be used for different purposes. On the one hand, for testing purposes. If something went wrong, and for example, the runtime test, you find an error, then it's quite simple to find which rule was applied, which rule was applied, why was it applied, and then you find out that this rule has to be changed. So this is one reason why this documentation helps. And on the other side, it's also helpful for internal or external auditors. For example, we did an IMS replacement for a German bank. And if doing so in Germany, there's a regulation organization called the BaFin. And when doing big changes to a software application of a bank, the BaFin performs audits. And of course, they wanted to know what we did to the bank's software. And for them, this documentation was very helpful to see what we did and to say, okay, that transformation was okay, and it may be put to production. So therefore, it's quite good. So these are the advantages of the commons. But when you look at the source, you also see there's a disadvantage. Of course, for testing reasons during the project, they're helpful. But when you imagine you have thousands of such commons in your source code and you have to maintain it after the project, you don't want to do that. And that's the advantage of the factory again. It's not mourning if it has to do a work twice and even more. So it's quite simple to configure the factory in a way that it's generating or transforming the source code in two ways. Once together with the commons, and one version without commons. So for testing or audit reasons, you can use the commented version, and for further maintenance, the uncommented version can be used. So that's about documentation. And then an optional mechanism to increase the security are so-called switches. The idea is, instead of directly replacing the IMS call, is to add a further call to the data service so that you have the access to the IMS DB and to the relational database in parallel. In this case, you have different switches. For example, there could be 4, where switch 1 means you have only access to the IMS DB. So it's like it was in the original source code. The second switch is you can access IMS and the relational database in parallel, but IMS DB is leading, means the application is reading both types of data, but is working with the IMS data. Switch 3 is you have access to both databases, but the relational database is leading. And switch 4 is only access to the relational database. That's where you want to get. And there is one switch per IMS database table. Yeah, so this can be used for testing in a test environment, but it can also be used in the productive environment if that's what you want. In that case, you can have a smooth way to get from the IMS DB to the relational database. And as long as you use switch 2 or 3, there's always the way back to IMS if you find out something is going wrong. And during the test phase, you can add a so-called verify and an error protocol. That means when switches 2 and 3 are used, so the parallel access to IMS and relational database, in that case, an automated comparison of the data is possible. You read both databases and compare the data. And you can even consider special cases like low value versus 0 or something like that. And in case of differences between the data, they are put into the error protocol, and you get a complete and detailed documentation of revealed differences in your systems, and then you can check what went wrong, which of the transformation rules has to be corrected. So this is a further security mechanism to ensure or to ease your tests. Yeah, and actually that's already we already achieved what we wanted to achieve. We successfully replaced our IMS DB. By using automation, we allow customization, meaning the solution, but also the process can be adapted to customer's requirement. So the customer does not have to take what he gets. It's not one size fits all. It's really made for the customer. The solution is flexible. The strategy can be changed regarding to the solution and the process at any time during the project, which in all projects we did before was quite useful. The solution is secure because it's reproducible. You can transform the data, the sources as often as you like. It's testable. The test effort can be reduced by a factory-based approach, and it's comprehensible internally or also for external auditors. And of course, for the developers who have to work with the sources later on and have to maintain them. A point which was not mentioned so far, but which is, of course, a big point in a project like this is performance. IMS DB is said to be real performant, and when you go or when you change to a relational database, all clients have or fear that the performance is not good enough anymore. And our experience is that when the factory developers, together with the database administrators and application developers of the customer, take the topic performance into account together, this problem is solvable. So far, in all projects, it was possible to achieve a suitable or even a good performance in the relational database with the relational databases. And by automation, it is possible to ensure that during the setup and the transformation time, there are no restrictions to the regular maintenance and to the daily business. But what was one of the, or is another really big point in this project is a close interaction with the customer, so that he really gets what he needs. And in the projects I mentioned at the beginning, as well as with Provincial, as also with Gotha, we had great parties at the end of the project, because both sides were really pleased with the result, because we really successfully replaced the IMS DBs together. It's never only the one company, but it has to be done together. And yeah, that's already, that was the successful way we went together with some customers. I hope I could give you some impression how it is possible to replace successfully IMS DB. And I'm looking forward for your questions. Thank you.
Thank you. I know there was a lot of conversation in the chat during your presentation. Are there any lingering questions? I do see one from Karen. Did you try this with FastPath DEDBS? She's wondering about, there's a question, the last question that came in from Karen.
Yeah. 1 second. Scroll down. The performance, yeah, it's a big topic. How did we achieve the performance? The performance was, of course, it was measured with the IMS and then compared with the DB2 in that case. And then when there were problems, there weren't problems in all pieces, but there were, of course, problems. Each of the problems had to be taken account separately. And in some cases, it was necessary to adapt the data model, the DB2 data model, to ensure that the performance is suitable or even good. And in some cases, we had to change the way the sources got transformed, or the SQL coding within the data services had to be adapted so that it fit to the customer's infrastructure and to achieve the performance. Is that a question to your answer?
I believe what Karen was actually asking is a FastPath database in IMS is a very specific type of database. and it's designed for very, very fast access, things like ATM machines and things like that. So she's asking, did you do any of your performance testing with those types of databases? Because the structure in those databases is set up for speed and for performance, whereas I don't believe DB2 has any kind of an equivalent to what a FastPath database is in IMS. That's what I believe Karen was asking.
So the performance test was done by the customer, so I don't know all details about it. I don't know whether, Michael, are you in the line too? Sorry, because Michael is one of our customers and he wanted to join today, but it seems he's not there.
Oh, I'm in. I'm in.
Ah, sorry.
Yeah, but we don't have a FastPath database, so I can't say anything about the performance of migrating FastPath database. Sorry.
Okay, because then in that case we didn't have that at Gotha, and we didn't either in the Provinzial project, and I can't remember the banking project, so I don't know. I'm sorry.
No worries.
Okay. About the data model, when indexes were needed, we added them, and when we don't need them, we didn't edit them. So depending on what was needed and what was required by the customer.
In our cases at Gotha, we work together with our DB2 administration, and together with Delta, we added some more indices, so we get a very, very fast performance. It's comparable to the performance we had before with only IMSDBs. But you have to test it.
Okay, I scrolled up the chat, and there was a question how long. I said it takes some time. Yes, that's right, but I didn't say how long is long. That depends. We had one customer where it needed 4 years, and with Gotha we needed 2 years from the beginning of the project till the last database was put into production. So the last package was put into production. And the question about above was who would want to take that risk? Yeah, it is a risk, of course, but there are reasons why to take that risk. And that's not only because of costs. The risks are, for example, because of the loss or the of knowledge about IMS, and because IMS is hindering adaptations for the future. And there are many reasons. I mean, we do not tell anyone you have to leave or you have to replace your IMS database. It's the other way around. The customers ask us, can you help us? Because we have some reasons. And these reasons make us or force us to take this risk. Or we believe we are forced by these reasons to take this risk. So it's not that we tell anyone to do that. So it's the other way around. The customers ask us why we should do it or not. I think there was another question about whether there is a system freeze. when I read it correctly. No, there's no system freeze. So we're really working in parallel, and maintenance and daily business are not disturbed at all. And the setup of the factory takes some time, but the transformation of the sources, even if you have to transform all sources at a time, can, for example, be done at a weekend. That's at least our experience. So means it's possible to hand over all sources on Friday from the customer to the factory, and the factory hands back the sources on Monday morning, so that there is no freeze. And the work maintenance can continue without any freeze. And you need a good fallback plan. A fallback plan yeah, there is the possibility of the switches, so you can switch back to IMS DB. But actually, in production, we never had really problems, so a fallback plan was needed. This transformation was tested up front, and all problems could be found during the test. So it really worked in production without any problems. Biggest risk is losing the IMS support team in the first month. To be honest, in most companies or most customers where we worked, was that even the IMS TBAs were keen to work on that project, and were looking forward to their new tasks after the project. So I think we didn't lose anyone of the team at customer side. Yes, by IMS table, I meant segment. There was a question of Colin. Seems you would need considerable IMS people resources. Well, that's exactly the problem the customers have. Then you have IMS people on the one hand, and DB2 or relational database knowledge on the other hand. Of course, to set up the factory, we have some questions to the IMS guys, but it was not a problem during the project, because there were questions asked, and we need DBAs for agreeing upon the database models, but they do not have that much more effort during the project. Does the data model solution works on ZOS platform? It works on ZOS platform, yes. but it could also be used for other platforms. If you want to move your database from ZOS to another platform, of course, it also works for another platform. But so far we stayed at ZOS, and it was a preparing step to then migrate or further transform the application to another platform. Karen said, and so to set up mentorship within the department. Okay, this is a discussion. Yeah, okay, education would be an answer, would be a solution too, but yeah, if it's lost knowledge. Does the factory runs at customer's place? Yes and no. In most cases, it has to be set up by us. If it's a requirement, it can run at customer size. In most cases, it runs at our site, but it would be possible to install it on customer site too. Yes, but in that case, we'd need access to the factory from outside. No, the data services so far were always generated by us using a tool from us. So it's part of the factory. I hope I met all the questions. Are there more questions? Did I oversee one? Have you any further questions? Or are all questions answered?
It looks like all the questions are answered.
Okay.
Great. Well, I'm sure if you have additional questions that you could reach out and get those answered. Daniela, thank you so much for presenting today. Love this lively discussion. I think it's definitely, a topic that is top of mind and resonating with a lot of people. I'm going to share my screen real quick to wrap us up for today. And I will say to this session video, transcript, and the presentation deck will be available on on the user group website, virtualusergroups.com. So you'll be able to check it out. Give us about a week to get all of that posted, and you'll be able to follow up there. Let me make sure I'm sharing the right screen. Okay. So for some articles and news, I just wanted to do a plug for our sponsor, BMC. They've got their AMI data for IMS tool that you can take advantage of. These are QR codes that you can just grab with your phone, or a lot of times we feature these links in our newsletter that comes out. So if you're not subscribed to that, please go to Virtual User Groups and subscribe. We also have a job on the job board at Planet Mainframe, AVP of Systems at Chubb, that is looking for IMS expertise. So I encourage you to check that out if you are looking to make a change this year. And as always, we're looking for contributors at Planet Mainframe. So you can submit any ideas for articles or videos or blogs through our website. So stay in touch with us. We are on most of your social media platforms. We are on X, Facebook, LinkedIn, and of course, we post these videos on YouTube as well. You can find our whole catalog of videos on YouTube. So don't forget to check those out. Lastly, I will thank, second to last, I will thank our partner, BMC, for their support. And I hope to see you at our next meeting on April 9th, where we'll host Steve Nathan. He is an author, a longtime IBMer, and he brings 40 years of experience as an IMS developer. So we will see you back here on Zoom April 9th. And I want to thank you all for participating today. And again, Dr. Schilling, thank you so much.
Thank you.
All right, y'all have a great rest of the day.